ask you about when it comes to finite and infinite series is going to be actually writing backwards. So I'm going to give you a sequence and you have to write it in some formation. There's 3 steps. The first step is to find the geometric sequence. After you find the geometric sequence, the next step is to find the end, and that'll make sense in a moment. And then the third step is just to write with sigma notation. And guys, remember sigma notation is that Greek-looking symbol that means to add everything up. All right, let's go ahead and start with step 1. We're going to write the geometric sequence. So we know this is a sub 1. We know this is a sub 2. I have no idea what this is, so that's going to be a sub n. Let's talk about what the common ratio is. What are all these multiplied by? How does 7 get to be a 14? So our geometric sequence, a sub n, equals a sub 1, which is 7. And remember, this is going to be 2, and it's always raised to the n minus 1 power. That's step 1. Now remember, step 2 is to find the n. This is where we're going to stop, but I don't know what place value 896 is. So we're going to replace 896 with a sub n. So 896 is going to go right here. And we are going to solve to figure out what place it's in. So let's go ahead and get rid of that 7. Let's divide both sides by 7. Guys, do this on your calculator. Have this on your calculator for sure. So 896 divided by 7 is going to be 128. So 128 is going to equal 2 raised to the n minus 1. Now listen, you have to solve for an exponent. When you solve for exponents, you either drop the base or you write a log. In this chapter, you're never going to have to write a log, which means 128 has to be a power of 2. And guys, I can't do prime factorization on this calculator, but I know it's going to be a power of 2. What I can do is divide by 2 and count how many times until I reach 1. Watch what I can do. I'm going to divide by 2. That's 1. There's 2, 3, 4, 5, 6, 7. I divided by 2. Sometimes I can check it. I can hit 2 raised to the 7th power, make sure I get 128, and I do. So I'm going to replace 128 with 2 to the 7. And you can drop the base. Guys, what's in?
8.
It sure is. Okay, we now have everything we need to write in some formation. All we're going to do, guys, is we're going to replace this front part, even the equal sign. All of that's getting replaced with this notation. So the answer is going to look like this. We started where n equals 1. We just found out that the last place was 8. And all you need to do is recopy this right side of your geometric sequence. And that's it. That is written in summation notation. All right, guys, we're going to do it one more time. If you notice in problem 9, the signs alternate. So the R value is going to be negative. Let's figure out what's happening here. Let's go ahead and find the geometric sequence. We know the first number is 15. I don't know the common ratio yet. Guys, look, 15 goes to a 3. Is it getting larger or smaller? Then you're multiplying by a fraction. 15 times what fraction makes 3? What is it? Yes, good job. And we're going to make it negative 1/5 because the signs are alternating. Any questions where the negative 1/5 came from? Okay, that was step 1. Let's figure out where it ends. So I don't know where it ends, but I know that this term is negative 3 over 625. So I'm going to replace a sub n with negative 3 over 625. And we're going to solve for n. Now, guys, over here, I did divide by 7 because it was a whole number. Since this is a fraction, I'm multiplying both sides by the reciprocal of 15. So these are going to cancel out. I'm going to be left with this over here on the right side of the equal sign. On the left side of the equal sign, the 3 and the 5 do cancel. 3 goes into itself once. 3 goes into 15 5 times. So over on this side, it's going to be negative 1 over whatever 5 times 625 is. Which is 3125. Any questions up to this point? Y'all, I know 3125 is a power of 5 because my teacher told me there's no logs. It's always going to be the same base. So again, I'm going to take this and I'm going to divide by 5 and I'm going to count how many times I hit enter until I reach 1. So when I divide by 5, that's 1, 2, 3, 4, 5. I can check it. I can do 5 raised to the 5th power, make sure I get 3125, and I do. So I know that this is this. Now you can drop the base and you can easily see what n equals. What does n equal?
6.
It does. So that's going to be the end of the finite summation. It is from the first term to the 6th term. So let's use our appropriate notation. Just don't forget to write n minus 1. You don't need an equal sign or anything like that. But you do need your end point at the top and you need your starting point at the bottom of that symbol. That's it.